Okay, so welcome to week 7. I'll just start out by apologising profusely for all the difficulties that we've been having in terms of technology. Once again, technology has let us down, and so this is the second best option. So the reason why we haven't been using pre-recorded lectures in this course in particular is because we know that teaching is really a dialogue between two people. Good teaching should be interactive. So my preference is actually to conduct these lectures using an interactive mode such as Collaborate, but unfortunately Collaborate is a heap of rubbish. So we're not going to use Collaborate Ultra next trimester. We're going to revert back to the old version of Collaborate, which I actually know works, okay? Anywho, enough about my problems, let's talk about the mathematics. So, week 6, we were looking at the substrand of Patterns and Algebra, and the reason why we've actually pulled this out and just looking at this substrand of algebra in particular is because it becomes much more important later on, okay? So rather than combining it with the other number and algebra substrands, I've decided to pull it apart and deal with it in isolation because it's so fundamental to much of the work that your students will actually be doing in high school, which is why we're handling it as a separate topic. Okay? So let's have a look at the learning objectives for week 6 in Patterns and Algebra. We're going to start off with a mind map. Okay, so we're going to have a look at the content descriptors, and then we are going to mind map that. Now, I've already created a mind map, so what I'll be doing is I'll just be talking through the mind map that I have. Okay, we're also going to be classifying familiar objects, which is based on one of the learning objects. And more importantly, what I want to do this lecture is actually expand your notion of what we think of patterns. So generally when we think of patterns, we think of visual patterns, but I really want you to think about, okay, how can I incorporate not only auditory patterns into my teaching, okay, especially if you have a music background, but also kinesthetic patterns. So if you have a dance background, you're able to bring that into your mathematics practice, especially with the littlies. So remember, what we should be doing with our younger students is making it very much play-based and including as much activity as we can. And by looking at auditory and kinesthetic patterns, not only do we hit a cross-curriculum what word am I looking for? A cross-curriculum kind of imperative, educational imperative, but we're also widening the experience of students as well in terms of, okay, yes, there are visual patterns and they are the majority of patterns that we do in mathematics, but we can also see patterns in other areas as well, such as music and such as dance. So let's move on to the content descriptors. So when we have a look at the content descriptors, they are there, so they are just copy and pasted. What's more important for us, and you should be noticing this as a recurring theme each week, is that this is the thematic analysis of the Patterns and Algebra strand. So this should just be a reminder because you've been doing this, hopefully you've been already doing this, you've gone through this exercise. So let's just very quickly go through the content descriptors for this particular substrand. So we can see that we're dealing with sorting and classifying quite early on, okay? And this is an activity that in terms of student play that they will quite often do. So for example, I remember having my toy cars in front of me and actually realizing, oh, there are some of these familiar objects which are cars and some which are trucks, okay? Or I remember I had miniature soldiers as well, those little green figurines that were made famous in the Toy Story movies. Well, I noticed that, oh, some of them are positioned like this and others are positioned in the kneeling position. So already thinking back, I could see, oh, I was already sorting and classifying. And it's not sorting and classifying of numbers, of written numbers just yet, because they get introduced later, but we're looking at familiar objects. So you can see the constructivist nature, once again, pardon me, within the curriculum of looking at familiar, so when we look at the constructivist continua, we're dealing with familiar objects first before we're moving on to more unfamiliar topics such as numbers. Okay? We're also looking at patterns with objects and drawings. So objects, once again, drawing upon that familiar. So using toy cars, using blocks, using coloured counters and squares and so forth. So foundation is our little preppies. So we should be dealing with familiar objects. Year 1, we're starting to, they've learnt their numbers, and now we're starting to look at patterns within numbers. So we're starting to investigate those patterns. A key skill that students will be working on, not only in year 1, but also much further on, and we touch upon this concept again of skip counting when it comes to having students fully understand their multiplication times tables, for example. Because you can practice skip counting in twos, for example, 2, 4, 6, 8, 10, 12, and so forth. Well, they are your twos times tables. And if you skip count in threes, well, they are your 3 times tables, and so forth. So you can see that the seeds of the multiplication timetables are planted quite early here in year 1, and we pick up again that concept later on. And what we call that in education is the concept of spiraling. That we introduce a concept at 1 year level and we revisit it again and revisit it again, but each time we revisit it at a higher level. So not only are we doing number patterns, but we're continuing our work with patterns with objects. In year 2, we're starting to describe these patterns with numbers and also identifying missing elements. Okay? And if you don't know what that is, that's okay. We'll be explaining what that is later on in this lecture. We're starting to also solve number problems by using number sentences. Now, you've kind of got the edge on this because we've been doing this all along. Okay? Every time we have created that problem for our videos, you have been creating, okay, a problem like this, and you've essentially been creating a number sentence. Now, in year 2, that number sentence focuses on addition and subtraction, and later on we pick up multiplication and division. But once again, you can see the constructivist nature of the curriculum in terms of starting with simple concepts and moving to more complex concepts later on. In year 3, we're upping the ante. So first of all, it was just describe and then identify. Now we're focusing on describe, continue, and create. So students are coming up with their own number patterns now. Okay? And we're still keeping it simple, focusing on addition and subtraction. Okay? Now let's go have a look at what that looks like when we look at that in terms of a concept map. Okay? So I will just go into my concept map here. Waiting. Now, while that's loading, let's keep, is it coming? Yes, it is. Okay. We'll just wait a few more seconds for it to load. And this reminds me, I shall probably preload the other one. Okay. But one of the ways of representing your summary is as a concept map. So I'll just zoom into Foundation first. Here are those content descriptors. So in Foundation, with familiar objects, students are sorting and classifying, but they're explaining their classification. Students are working with objects and drawings, and we want them to copy, continue, and create. When we come into Year 1, we're moving away from objects and drawings into number patterns. So we want students to investigate, describe, and that skip counting concept is introduced, and also patterns with numbers. So in Year 2, here we go with number patterns identifying that missing element. And we're also looking at number sentences focusing on addition and subtraction. Year 3, number patterns again, but this time remember, this is where students are creating their own number patterns. They're describing that number pattern and they're continuing. So what we want students to do is also look at moving from in the positive sense towards the positive direction on the number line, but also in the negative sense. So we want students counting up as well as counting down. Skip counting up and skip counting down. So remember that skip counting begins back here in Year 1, and we pick that theme up again in Year 3. Okay, so there is the concept map of patterns and algebra when it comes to the younger years. So Foundation, Year 1, Year 2, and Year 3. Okay, so let's return to the lecture slide. That's not it. Over here. So let's look at what we're requiring students to do. So here's an activity that what I'd like you to do is to pause this video, and I want you to challenge yourself. How many different ways can you classify these animals? So we've got a bear, a snake, an ant, lizard, fish, snail, bird, bee, toad, brontosaurus, spider, worm. How many different ways can you split those into, say, 2 groups or 3 groups? Okay, obviously 2 groups is easier than 3 groups, okay? But that's going to be up to you. So think about how many different ways we can classify these animals. And also, so imagine that you had these as little toy figurines, a lizard, an ant, and so forth. What activity could you do with your prep students? So remember, the focus of these lectures is to help you complete your e-portfolio, and this is an excellent example of an activity that you could design for your e-portfolio. Okay. So let's start off by, let's go to looking at patterns now. So the most obvious patterns that we can investigate, well, the most obvious ones in mathematics are visual patterns. So you have patterns like this, and you have, so these are more traditional number patterns, but you can see how that you can look at number patterns either symbolically. So remember the CPA progression that we've been looking at throughout this course. We can look at the pattern symbolically 2, 4, 6, 8, 10, but we can also look at that pattern visually in terms of 2 dots, then 2 lots of 2, then 3 lots of 2, then 4 lots of 2, and 5 lots of 2. But what's important is that connection between the pictorial representation and the abstract representation. Here that pattern's extended to the 3s. So we're now skip counting in 3, 3, 6, 9, 12, 15, and so forth. So here's that visual representation. A pictorial representation, so 3 blocks stacked on one another, 2 lots of 3, 3 lots of 3, 4, 5 lots of 3. Okay. Here's another example of skip counting, much more complex. Probably you wouldn't do this with your littlies, but it's skip counting in nines. So we got 9 visually represented, 18 visually represented, and 27 visually represented. Okay? Rightio. So we can also see patterns over here. So remember, one of the content descriptors is extending patterns. So we have a square, we have a circle, we have a square, we have another circle. So the job for the students is to figure out, you tell me, what is the next object in this sequence? Now, while these are drawings, more than likely the way that you'll introduce this to students is with concrete circles, actual circle counters and square counters. This is where you get your geometric shapes out. So you've got a pentagon, followed by a circle, followed by a pentagon. What would be the next shape? Slight variation on patterns. So we've got a parallelogram, another parallelogram, then a triangle. I wonder what the next one would be. So this would be a great activity where you would do this. So remember explicit instruction. You would model this question here for students. So circle, square, circle, and so then you'd place a square. So you would use concrete materials to complete this problem, whereas students working back at their desks will be filling in this worksheet. So not only would you just fill in the next item in the sequence, but you would be asking students to extend that sequence. Can they see a pattern? Circle, square, circle, and so forth, okay? So you can see here, this is a slight variation on that pattern. So, let's just come back to that explicit instruction idea, where you would role model this. This would be the I do portion of the lesson. This would be the we do portion of the lesson. And then the next 3 problems would be the you do, the independent practice by students back at their desks. So you would challenge them, okay, think carefully now, students. We have a parallelogram, triangle. What would be, say, the next 3 objects in this sequence? Then we got a trapezium, a circle trapezium, an arrow, hexagon, arrow. And you'd be asking them to extend that pattern. Okay? Rightio, let's have a look at the other patterns, because not only do we have visual patterns, yes, we have visual patterns, but we also have auditory patterns. And in this last activity, where we were extending that pattern, this is a visual representation of music, of where we would present students with some beats to play, and they would repeat those beats until we tell them to stop. That's essentially what a lot of music is. So for example, so those of you who understand music, you'd understand that these are crotchets, and crotchets mean that they are 1 beat per note. Okay, so we have, so if I use tars to represent these rhythms, and so I'll say them out. Okay, so this rhythm would be ta, 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 ta. I'm sure you get the idea. Okay, this pattern here is we've got 3 crotchets followed by 2 quavers. So the way that we would play this is ta, 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 ta. So if you're doing this with your students, and if you have a background in music, this is an excellent time to bring it in. So you would probably have students say tars, tars, or whatever. You could have students clap. So you would clap it out, you would say it out. So students would clap and they would say each one of these rhythms. So ta, 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 ti, ti, ta, 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 ti, ti, ta, and so forth. This pattern down here is ta, ti, ti, ta, 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 ti, ti, ta, 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 ti, ti, ta, ta. So, so hopefully what you were doing as I was playing and singing these patterns, hopefully you're playing along. So let's try it, okay? So either sing or clap this pattern as I'm saying it, okay? So just join in and I'll repeat it, say 3 or 4 times, and join in and just keep going, especially if you're new to music. This is where that just have a go attitude really comes in to tonight's lecture. So we've got ta, ti, ti, 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 ta, ti, ti. Okay, we'll stop there. And we've got more complex patterns. So there's a whole range of these auditory patterns. There are much, much more complex auditory patterns that you can be teaching your students. And this is a great way to bring in all of those percussion instruments, the tambourine, the clapsticks, clapping, the maracas, and so forth. So quite a lot of times we say, oh, that's the music teacher's job. Actually, you can have a bit of fun in mathematics by using these patterns. Now, if you know music, you can actually have some students play this line, ta, 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 ti, ti, ta, 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 ti, ti, and so forth, while another group of students plays this line, ta. Oh, so let's get a more interesting one. Let's go this one. Ti, ti, ta, ta. Ti, 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 ta, ta. Ti, 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 ta, ta. Ti, 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 ta, ta. Yeah? So what you're then introducing there is the concept of playing different parts within music. Okay? So teach your students these simple patterns, and then can you play them in a round? So there are a whole bunch of childhood songs that you can help students play in what we know musically as a round. Now, if you're brave enough, here are more complex patterns. Now, I'm not saying now go in on prac and teach students these patterns because it will freak them out. But these, so if you want to see where this can go to, this is an excellent example, okay? And body rhythms is utilized by a lot of schools in their music programs, okay? And this is where you can actually take it. So I won't actually play the video here, but I will leave it to you to explore later on. Now, I'm not going to spoil the surprise, but believe it or not, there are patterns within dance as well. Okay? Now, if you went to school in Australia, you'll be quite familiar with this dance because I'm not sure about you, but every child in my school learned how to do this particular dance. Now, I won't spoil the surprise. You go and watch this. Now, where this is, so this is a combination of the week 6 and week 7 lecture, and it's in the lecture slides folder. So I'll just show you where that is. Lecture slides, so Kevin's made his own folder. They're sitting right here. So there's the individual slides. There's the slide that I'm using tonight, okay? So please do go and have fun. So if you have a dance background, this is a great way of bringing dance into mathematics, okay? Rightio, the last concept for patterns and algebra that we're going to talk about tonight is this one here, the missing element. So it's, hopefully you can see, it's very much an extension of what we were doing earlier with the extender pattern, okay? Now what we're doing is, okay, well, here's a well-established, whoopsie, where am I? Here's a well-established pattern. Now, what's the missing element? Now, what will help students is if they say the pattern out loud. So, so this might be square, square, circle, circle, square, circle, circle. Okay? So, the challenge then, so can you see how it's much, much easier, especially for our early learners, to pick up, oh, I can hear the pattern of square, square, circle, circle, square, circle, circle. And that is obviously the missing element, and that will help your students. Because also remember that what we're doing is when we're going through the I do phase in explicit learning, we're teaching the thinking that students should be using to solve these problems, okay? So, I don't know what that shape is. So let's call it arrow, and let's call this one triangle. So we got arrow, arrow, triangle, 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 arrow, 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 triangle, triangle, triangle. I wonder what the pattern is. How would you fill in that element? And you go through a similar process as well. Okay, so this one's a little bit trickier. Okay, so have a good think about this one. Much, much trickier in terms of completing that one. This one is a little bit simpler again. So we've got diamond, triangle, 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 diamond, triangle. Okay, and hopefully, as you're teaching that auditory pattern to students, they're realizing, oh, sir, this is so easy, I know what the answer is. Okay, so we got, so once again, missing element. So trapezium, circle, 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 trapezium, circle, circle. Can you see how, when you say the pattern out loud, it makes the task infinitely easier for your students? And that's what we want. We want to lower the bar to allow students to fully engage in these activities, okay? So that brings us to the end of the week 6 lecture, and there are our learning objectives, which I won't go through again because I assume you can read. So let's move quickly on to week 7. Rightio, but before we start week 7, here's some more general feedback on your portfolios. So this point here was definitely mentioned by Gordon in terms of your referencing. So that we noticed that there was referencing missing from feedback you were given, especially if you're aiming for that 7. I cannot stress strongly enough how important it is you go and read the criteria sheet, because the criteria sheet explicitly states for that 7 level that you reference everything to within an inch of its life, okay? Also, this is something from me. I want you to keep in mind the bigger picture, the bigger goal, in that what you are creating, okay, yes, we are marking it as educators, and yes, we want to give you a mark so that you can get a bit of paper at the end of this 1.5 years, but what's more important to me is that you actually survive your first few years of teaching, because the number of teachers who actually drop out of teaching within their first 5 years is absolutely scary. And I don't want you to waste your time and money over these next 1.5 years, because you are spending a lot of money, you are spending a lot of time, you're sacrificing time, you know, sitting back with your kids, with your loved ones, with your friends, enjoying yourself. You're taking time out of, you're sacrificing your busy life to devote to your studies. And for you to get to, at the end of 1.5 years, and say 1 year into your teaching, and for you to realize, I've made a huge mistake, that I'm not well prepared enough, for me, that is the real travesty. Not that whether you get a 5 or a 6 in this course, because I fully appreciate, I have no doubt that many of you will actually smash this assessment out of the ballpark as previous students have. What I'm more worried about is that you actually survive out there in the jungle that is the classroom, okay? Also, we're kind of getting the sense that still people aren't devoting the full 10 hours. Now, this course and the assessment is explicitly designed to take that maximum of 10 hours, okay, for you to actually complete. Now, that's on average. Now, not every week will you spend 10 hours on your e-portfolio. Some weeks it'll be 15, okay? Other weeks it'll be 5, but on average it comes out to 10, okay? And what you'll find is that as you're progressing along, you won't need to spend that crazy 15, 16 number of hours on the e-portfolio, because you're really getting the gist and the flow of this course and the assessment piece. Okay, so let's dive, without further ado, let's dive into statistics and probability, okay, and chance and data. Okay, so we're actually going to deal with the last two, the last strand together. So this is statistics and probability, and this is data display. Okay, so this is statistics. Sorry, this is probability up here, and this is the statistics substrand. So once again, we've highlighted verbs and nouns. Notice again, familiar events, identifying outcomes, familiar events, everyday language, okay? Choosing simple questions. So hopefully you're really getting to understand the constructivist nature of the curriculum. It's not structured in terms of going from lower order thinking verbs to higher order thinking verbs. That is not one of the directives the curriculum writers were given. They were told for everything else apart from thinking skills, please use constructivist continuum. So let's focus on chance, probability to begin with. So we're starting with familiar language. We're getting students to describe their likelihood using everyday language. Will happen, won't happen, might happen. Okay? So you can see here quite simple categories, and 3 categories only. Definitely, nope, not on your nilly, and yeah, I think there's a chance. When it comes to year 2, we're starting to look at practical activities and everyday events. Okay, so practical activities would be like going to the library, going swimming, might be music lessons, it might be going to visit grandma. Those are the kind of practical activities that we're talking about, and everyday events as well. Okay, so for example, having breakfast, traveling to school, or it might be afternoon sport, for example, and so forth. It might be training for sport, it might be music lessons and so forth. Okay, nope, we're not there yet. Okay, so where in year 1 students were describing will happen, won't happen, might happen, in year 2 we're asking students to use, use likely or unlikely now, and identify events as certain or impossible. Okay, so that's almost like a step backwards where we had 3 categories here. Now we're using 2 categories, but what's important is we're shifting from everyday language to much more mathematical language. So likely and unlikely are mathematical terms. Certain and impossible are also mathematical terms. In year 3, students are starting to conduct these things called chance experiments. And so chance experiments would be things like rolling dice, picking marbles out of a bag. That's what we're talking about when we're talking about chance experiments. And so you're conducting very, very simple chance experiments, but you're also then identifying, describing the possible outcomes and recognizing variation in those results. So if you're flipping a coin, if you're rolling a dice, you might explore, is it more likely that we roll a 6 than a 1, for example? And that would be an appropriate investigation for Year 3 students. Let's look at the statistics now, and you should see that constructivist notion again. So we're starting off with simple questions, and students are actually going out and gathering responses. Okay? So it might be, what's your favorite ice cream? Or what's your favorite color? Who's your favorite NRL team? What sports did you watch at the on TV for the Commonwealth Games, and so forth? So simple questions requiring responses. Then what students are doing is representing that data with objects or drawings. Now, this is an important point. Drawings where one object or drawing represents one data value. Now, in many words, that is describing a picture graph. Okay? So, that is one of the quiz questions that you'll have this week. If you haven't already done so, that's what it's getting at. That's why that begins in Year 1, and it's actually then explicitly labelled in Year 2. So once students are creating these, so for example, it might be you're integrating home ec with your Year 1 students, and the activity that your home ec, that you're doing in home ec is making fruit salad. Okay? So in order to make that fruit salad, you need to know what the students' fruits are. So you might get them to line up at the front of the room, or you might have a great big bowl of plastic fruit, and students are to take out their favourite fruit and come and place it in a line on the floor at the front of the room as the graph. Okay? That would be objects. Okay? Then you could get students back at their desk to draw that graph using drawing apples, drawing oranges, drawing bananas, and so forth. Okay? And then having students describe the displays. So in terms of, so in terms of describing that display, which fruit was the most popular in class? Which fruit was the least popular in class? If we want to make a fruit salad of the top 5 fruits, what fruits would we be including in our fruit salad? Okay? Rightio, let's have a look at Year 2. Students are then being asked to identify a question of interest. So this is a question of interest to them. So it might be, oh, I want to know what the favourite cupcake of the students that are in my class, because my parents are making cupcakes and I'm bringing cupcakes to school tomorrow, and I want, you know, to make sure that my friends get their favourite cupcake. So once they've identified that question, then they go and gather that data. Once they've gathered that data, they collect, check, and then classify. So they might make up a tally sheet to classify that. Once they've created their tally sheet, then we're asking students, okay, can you display your data as a list, or as a table, or as a picture graph? Remember, it was first described back here in Year 1 as a picture graph, and can you interpret that? Okay? Rightio, then in Year 3, we're upping the intellectual ante again, where we're asking students, yes, can you identify, because for categorical variables, so categorical variables are variables which are categories. So for example, what's your favourite fruit? How did you get to school? What drink are you having at morning tea? They are categories. And you therefore would just simply count the number of people or the number of objects in each one of those categories. Students are also being asked to identify data sources and plan methods of data collection and recording. So here, students are designing a small survey. They're identifying data sources. Okay, is my data source the internet? Is my data source other students? Is my data source teachers perhaps? Okay, and so forth. They have to plan those methods, go out and record and collect. So collect your data and organize it into categories and display your data. So hopefully you can see once again, there's a clear progression going from year 1 to year 2 to year 3. Each time we're adding more and more intellectual demand to the particular activity. Okay? Now, I'll spare you, let's go and have a look at it. So, when we have a look at this particular graph, and we'll wait for that to load. Okay, so let's come down. So we've got statistics, so we've got chance. Okay, so let's look at chance first, just so that you have an image of what the completed concept map would look like. So this is a complete map from foundation all the way up to year 6, but we're just interested in the earlier years. So let's zoom all the way in. So you can see here the year 1 content descriptors, mind mapped. We can see the year 2 content descriptors and the year 3. Okay, so in year 3, where they're conducting chance experiments and looking at possible outcomes, they identify and describe, and they are to recognize any variation in the results. So there is the chance, whoopsie, wrong way. So there is the chance, substrand mind map. Let's have a quick look at the data representation and interpretation mind map, and it looks like this. Okay, so once again, it is all the way up to year 6. Yes, okay, and this is the beauty of working in something like MindMeister, is that you can actually, I'm just going to move that over. Yeah, come over there. Oops, actually, move you up here. Okay, and this is the beauty of MindMeister. So if this trimester you just do foundation year 1, year 2, year 3, you can revisit this in trimester 2 and do 4, 5, and 6. So let's quickly zoom in and have a look at what foundation are doing. So remember, foundation, they're just doing yes, no questions. Did you walk to school today? Yes or no? Are you having a sandwich for lunch? Yes or no? So they answer the question, collect information. So very much a binary option of yes, no. In year 1, we're looking at simple questions. So simple questions, they choose those simple questions, they gather responses. In terms of data displays, we're looking at data displays which have a one-to-one correspondence, where one object equals one data point, or one drawing equals one data point, and we're asking students to describe those data displays. Coming down to year 2, we're dealing with questions again, but these are interest-based, and we're asking students about categorical variables. Okay? So students gather that data, collect, they check and they classify that data, and in terms of data displays, well, you have an option. This investigation you might use a list, next investigation you might use a table, next one you might use a picture graph. So we're looking at different data displays so students are exposed to all the different ways that data can be displayed, and we're also still asking students to interpret. Let's move down to year 3. Where's year 3? Here we are. Okay? So year 3, so questions, categorical again. Okay? Data sources, students now need to identify their own data source, but they are to plan the collection and the recording of their data. We're handing that control over to students. There are more data displays. So lists, tables, picture graphs, simple column graphs. So you can see how this is a much more abstract representation of a picture graph. Okay? And what this acronym means is with or without technology. So you want students to be able to draw these objects, but you also want to introduce them to Excel. So not only do you want them to interpret, but also compare. Okay, and I'm just going to make that green while we're here. There we go, that's better. Don't know why that was like that. Okay, so there we have data representation and interpretation. Okay, and that's what it would be. So next trimester, we're going to proceed along this side over here. Okay, but we'll leave that to next trimester. Let's come back to the PowerPoint. Okay, so let's quickly whip through these so you can get to more interesting things. So in terms of chance, dice are cheap, dice are everywhere, and what's great about dice is they are familiar, especially if students have board games at home. So there's Yahtzee, there's Snakes and Ladders. I still remember that this was a childhood game. We had Yahtzee when we got a little bit older. Okay, so here's a game for students to play. So in here, so what we want is students to roll dice, okay, and then to cover up, okay. Hang on, what does that say? Roll. Okay, I'm just going to zoom in so we can actually read the instructions. Roll one die and double your answer. Place your marker on the grid. Ooh, this is great. Okay, so you're introducing a little bit of chance here. So this could almost be like a race where you have groups of students working. So they're going to roll their dice, whatever it is, they double, and then they say colour in. So it's like a form of bingo for the students. Okay, so double 1 you get 2, double 3 you get 6, 8, 12, 10, 12 and so forth. Okay, so here's that similar concept over here where students roll, they put dice into this cup and they roll until they match the dice down here. Here's a simpler one. So once again, students roll, and when it matches these empty places on the lady beetle, they then cover up the lady beetle. Okay, now this can get quite noisy, so you might want students to work on the floor rather than on their desk or on a wooden desk. Okay, now in terms of every day, what can we do every day? Well, quite a common feature of many primary school classrooms in the morning meeting is that they will track the weather. So for example, is it sunny, is it partly cloudy, and is it rainy, and so forth. So what they can do is actually track how many days over the month was sunny, partly cloudy, and so forth. Here's another example of that graph, but in this case it's more of a picture graph. So if it's sunny today, then you place an icon here. If it's rainy today, place an icon here. Now we don't have snow, so we wouldn't have this column here, but we would have weather graphs which are specific for us. Down here, this is another way of recording. So days of the week, we've got the days of the month that it is, and also the weather representation. In terms of every day, we can also look at sports. So if you are in a school where the kids are absolutely NRL crazy, we'll tap into that. If you are in a school that are absolutely netball crazy, then tap into that. What we are advocating here is that you tap into the interests of the students and also the community. It's not always about us. So there's no point you, for example, having students look at the women's volleyball Philippines League, for example, which is what I watched on the weekend. Okay? You would actually use something which is much more local, much more familiar to your students. Now in terms of object graphs, now this is something I made up, here are some great investigations. So here's that apple activity, okay? So here, classifying apples, placing them in a line and getting a good kinesthetic sense of what a graph should look like. Here's a boy, this would be me when I was younger, lining up all my toy cars like this. Okay, so here he's doing that classification. Here we've got students and they're lined up in their month of birth. Okay, so here you can see October, November, December would be here, and so forth. Here are those counting teddies that you've probably seen if you've come along to a workshop. We've got red teddy, blue teddies, and so forth. In each instance, what's important, oh, this is footwear worn to school. So I can't quite read. So these are people who wore thongs to school, people who wore sneakers to school, and people who wore other to school. Okay, so you can see they're all lined up, and so you can see that many more people wore thongs at this particular school. Okay, excellent. Now, in terms of data for the Little ones, where we had these object graphs, where we would go to next are more pictorial representations. So, for example, here's a great activity. You might be integrating with home ec again, and you're interested to find out, rightio class, we're going to make pizzas, but we don't want to put foods that we don't like. So for example, anchovies, we don't want to put anchovies on. Well, you get to vote on the toppings for our pizza. And obviously the winners, cheese you must have, okay, tomato paste you must have, but then there are optional toppings, and this is where students get to decide. Here's favourite apples, okay? So if you ever teach in an apple growing region, so you can look at different types of apples. Here is how many people in your family. So this is where students are, say, drawing the members of their family in their class. So no people have 2 people in their family, that's not surprising. Or it might just be, say, a single parent and a single child living in a household. This might be just mum, dad and 2 kids, or mum and 2 kids, or grandma and 2 kids. Here is mum, dad and say a bunch of kids. Some people may include their pets as part of their family. So hopefully what you can see is that there is a whole range of contexts that you can use, whole bunch of materials you can use to represent graphing. You don't always have to draw graphs. You do have options as teachers. And if you are teaching constructivistly, then this is definitely the route that you should be taking to get to a much more traditional graph like this. Okay, so this is that fruit survey which was done before. What's the nicest fruit? You can see we've now got a scale. It's not a 1-to-1 because it's purely a bar. So in this class, there are many more people whose favourite fruit is blueberry. Next would be apple, orange, kiwi fruit, banana, and then finally grapes. Okay, so hopefully you can see there's a clear progression moving from objects to pictures, then on to the more standard representations of graphs that we have. Okay, rightio, there are other graphs as well. So here's a great sorting activity. So students are to sort according to 5 petals, and I think that's blue, I think. Yeah, or I can't quite, oh, hang on, I'll just zoom in. That would be the solution. Oops, nope, let's go down. Let's go down again. Oh, it is blue, yeah? Okay, so here we've got flowers with 5 petals and blue flowers. And any flowers which are blue and have 5 petals would obviously go in the middle. Okay? Here is a great activity that to engage your students is using chocolates. Okay? Now you just need to check with the school policy on using chocolates and sweets within your classroom. So this is one activity that you can use. Here is what's your, within a packet of fun size M&Ms, let's graph the number of different colors, and then let's go around and compare what we see between each of the graphs. So that's the activity here. So here we got many more green, one yellow, one orange, one red, one whatever that color is, purple. Okay, so you can see the data represented in terms of a bar graph, data represented in terms of a pie chart, and then there are the different types of charts that you can use. Okay, now, so that is all for tonight. So hopefully you can see how, as we've gone along, we're not spending the full 2 hours together. So you now have more time to spend on other elements. Okay. So thank you very much for listening to this lecture, and I will see you around. Okay. Bye, everybody.